Today we start a new chapter in science, that is acid, bases and salts. Now before I teach what are acids, let us look at the examples of acids, examples of bases and examples of salts. Acids that we know about are hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid. Now if you look at all these acids very carefully, then you will notice that there is something common in all these compounds. And the common is all of them have H plus ion as cation. So when they are dissolved in water, these ions will be produced. This is common in all the acids. So acids will always have H plus ion as the cation. If you look at all the bases, again you will notice that there is something common in all the bases. If you look at sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, ammonium hydroxide, then they have hydroxide common in them as anion. So when they are put in solution in water, they will produce hydroxide ions as anions in solution. Now let us look at the examples of salts, that is sodium chloride, copper sulfate, potassium iodide, lead nitrate and calcium carbonate. The list is infinite. In all these compounds you don't find anything common. So in salts the cation is other than H plus ion. That means H plus ion is not there. Any other ion will be cation. Or there should be no hydroxide ion. So cation is other than H plus ion and anion is other than hydroxide ion. Those substances that don't have H plus ion as cation and OH minus as anions are called as salts. But if the compound has hydroxide ion as the anion, then it is a base. And if the compound has H plus ion as the cation, then it is acid. This is how you will identify by looking at the formula whether the given compound is an acid, it is a base or a salt. Now let us study about the properties of acids and bases. The first is definition of acid. Acids are substances that produce H plus ions when they are dissolved in water, that is aqueous solution. Whereas base will produce hydroxide ions in aqueous solution, or they may be oxides of metals. So those are base. Acids are sour to taste, which you have already tasted. Citric acid that is present in citrus fruits is sour to taste because it is acid in nature. Whereas base are bitter to taste. Now if you take litmus paper and hold it in acid, then blue litmus will turn red. Whereas base will turn red litmus blue. Similarly, a solution of phenolphthalein which is colorless will remain colorless if 2 drops of phenolphthalein solutions are put in acid. But if you put phenolphthalein solution in base, then this solution will give a pink coloration to the solution and the solution will turn pink. So phenolphthalein is pink in base, it is colorless in acid. Another solution that we can use to find out whether the solution is acid or base is methyl orange. Methyl orange solution is orange in color. If you put it in acid, then the solution will turn pink. And methyl orange, which is orange in color, in basic medium will turn yellow in color. These solutions like litmus, phenolphthalein, methyl orange, which will show different colors in acids and bases, are called as indicators. So I just mentioned examples of indicators. Litmus solution which is purple in color. in acid and it will be blue in base. Phenolphthalein is a colorless solution which will be colorless in acid and pink in base. Whereas methyl orange, which is orange in color, will turn pink in acid and yellow in base. So that means these solutions have different colors in acid and basic medium. So these substances which will help us to find out if a solution is acidic or basic are called as indicators. Now there are certain substances whose smell will change when they are in acidic or basic medium. Then those substances that will change smell in acid or base are called as olfactory indicators. Examples of olfactory indicators are onions and cloves. Let us now study certain chemical properties of acids. First property that we are studying is metal plus acid will give us salt and hydrogen gas. This is a displacement reaction. If you put zinc granules in hydrochloric acid, then you will get the salt which is zinc chloride. This you will predict by displacing hydrogen from HCl and hydrogen gas will be released. So you will see bubbles of hydrogen gas coming out of the solution when you put zinc granules in dilute hydrochloric acid. Similarly, if you put few granules of magnesium in sulfuric acid, you will also see hydrogen gas. And that is because magnesium is more reactive than hydrogen, so it will displace hydrogen from sulfuric acid, forming magnesium sulfate, and hydrogen gas is displaced. So the first property is when we put metals in acid solutions, you will always get a salt and hydrogen gas will be displaced, which will be seen in the form of bubbles. The second property that we have to learn is metal carbonate or metal hydrogen carbonate. When treated with acid, will give us salt, water and carbon dioxide gas. Let's take examples. Sodium carbonate. Sodium valency 1, carbonate 2, when you bring it here it is Na2CO3. Let us mix it with hydrochloric acid. Then the salt that you will get will be obtained by double displacement reaction and the salt is sodium chloride. Along with this, you will get water and carbon dioxide gas. So you will again see effervescence. Effervescence means bubbles, brisk bubbles of carbon dioxide gas. On the reactant side, we have 2 sodium, whereas on the product side, we have only 1. To make the number of sodium atoms equal, we multiply sodium chloride twice. Therefore, now we have 2 chlorine atoms on the product side, 1 on the reactant side. So I multiply HCl by 2 to make the number of chlorine atoms equal. If you count the number of hydrogen atoms on the reactant side, it is 2, and on the product side it is also 2. So hydrogen is also balanced. The number of carbon atoms on the reactant side is only 1 and the number of carbon atoms on the product side is also 1. So carbon is balanced. We have 3 oxygen on the reactant side and we have 1 plus 2, that is 3 oxygens on the product side. That balances the equation. So sodium carbonate when mixed with acid will release carbon dioxide gas. Instead of sodium carbonate, we can take sodium hydrogen carbonate. And we can mix it with acid HCl. Then the products also will be same. You will get salt, water, carbon dioxide. Since we have taken sodium hydrogen carbonate, the salt obtained will be sodium chloride. The other two products are water and carbon dioxide gas. On both sides of the equation, we have one sodium. We have 1 plus 1, 2 hydrogens on the reactant side and 2 hydrogens on the product side. We have 3 oxygen on the reactant side and 1 plus 2, 3 oxygens on the product side. We have 1 chlorine atoms on both sides. This is a self-balanced chemical equation. The third property of acids that we are studying is acid plus base will always react to form salt and water. Now this reaction is called neutralization reaction. Let us take example acid as HCl, base as NaOH. Then the salt obtained will be written by double displacement reaction, sodium chloride, and we'll get water. So when an acid and base will combine, then their effects will get neutralized and you will get salt and you will get a neutral solution, and therefore this reaction is called as neutralization reaction. If you look at the equation very carefully, then on both sides we have 1 sodium, we have 1 chlorine, we have 2 hydrogens on both sides of the equation and 1 oxygen. This is a self-balanced chemical equation. Let us take one more example of neutralization reaction. That is, sulfuric acid combines with potassium hydroxide. Sulfuric acid is an acid, potassium hydroxide is a base. You will get salt, and the salt obtained will be potassium sulfate. Now if we have to write the formula of potassium sulfate, we must know the valency of potassium and sulfate. Valency of potassium is 1, sulfate is 2, and therefore the formula is K2SO4, and you will get water. This is an unbalanced equation because the number of potassium atoms on both sides of the equation are not equal. So to make it equal, I will multiply KOH by 2. That makes the number of potassium atoms equal on both sides of the equation. On the reactant side, we have 2 plus 2 hydrogens. Total 4 hydrogens on the reactant side. So I will multiply water 2 times and make the number of hydrogen atoms equal. The number of sulfur atoms in sulfuric acid is only 1. The number of sulfur atoms in potassium sulfate is also 1. So the number of sulfur atoms are equal. Similarly, we have 4 plus 2 oxygen, that is total 6 oxygen atoms on reactant side, and 4 plus 2, that is 6 oxygen atoms on the product side. This equation is now balanced. The next property that we are learning is the reaction of metal oxide with acid. The fourth property that we are studying is the reaction of acid plus metal oxide. This will again react to form salt and water. To take an example, let us take hydrochloric acid and react it with copper oxide. Copper oxide is black in color. It is treated with sulfuric acid if I have to write the products, then it is a double displacement reaction. So copper and chlorine will react and the salt obtained will be copper chloride. And along with this, we will get what? Copper chloride is blue in color. So you will see, you will observe that the solution turns blue. This is an unbalanced chemical equation because we have two chlorine atoms and two hydrogen atoms on the product side, whereas the reactant side we have only one chlorine, one hydrogen. To make it equal, I multiply HCl by 2. That makes number of hydrogen atoms equal, chlorine atoms also equal. Copper we have 1 on both sides and 1 oxygen on both sides. Similarly, if you take hydrochloric acid and treat it with magnesium oxide, you will get magnesium chloride and you will get what? To balance it, we multiply by 2. Now, if you look at the fourth property and the third property, there is something common in it. The common factor is in both cases acid is reacting with a substance to form salt and water. So this reaction is similar to neutralization reaction. And since this reaction shows similarity to neutralization reactions, we can say that metal oxides are basic in nature. And that is because metal oxide will react with acid to form salt and water like in neutralization reaction. So always remember, metal oxides are basic in nature, are basic oxide. That means they will turn litmus blue. The fifth property that we have to learn is non-metallic oxide plus acid plus base to form salt and water. This is the fifth property. Let us take example of non-metallic oxide, that is carbon dioxide. Carbon is a non-metal. The oxide of it is carbon dioxide and therefore carbon dioxide is a non-metallic oxide. If we pass carbon dioxide into calcium carbonate or react it with calcium carbonate solution, then it is a double displacement reaction forming calcium carbonate, that is the salt, and we will get water. This reaction is self-balanced because there is one calcium atom on both sides, we have one carbon atom on both sides, we have 2 plus 2 oxygen on reactant side, that is 4, and we have 3 plus 1, 4 oxygen atoms on the product side, we have 2 hydrogen atoms on the reactant side and 2 on the product side. So it is self-balanced. If you look at this reaction and the third property, then again you will find that they are similar. And this is because a substance is reacting with a base to form salt and water. So these two properties are same. So this reaction is also similar to neutralization. And since non-metallic oxide react with base to form salt and water, like acids react with base to form salt and water, we conclude that non-metallic oxides are acidic in nature, which you have already studied as acid rain. In acid rain, gases like sulfur dioxide and nitrogen dioxide are dissolved in rainwater and come down as acid rain. This is because sulfur is a non-metal and sulfur dioxide is a non-metallic oxide. Similarly, nitrogen is a non-metal. The oxide of nitrogen, that is nitrogen dioxide, is also non-metallic, And just now we have said that non-metallic oxides are acidic in nature, and therefore these gases, sulfur dioxide and nitrogen dioxide, are also acidic gases. So when they dissolve in rainwater, they form acid rain. So we studied 5 properties of acids. We shall now learn one test to identify carbon dioxide in solution. If we are given a gas and we want to find out whether the gas is carbon dioxide, then we pass it into lime water. So test for carbon dioxide. Carbon dioxide gas turns lime water milky. This is to find out whether the given gas is carbon dioxide. Now lime water is nothing but a solution of calcium hydroxide. This is lime water. So when we pass carbon dioxide into lime water, the lime water which is transparent will turn milky. Now let us understand why the lime water turns milky. We just wrote a reaction in which carbon dioxide reacts with a solution of calcium hydroxide, which we call as lime water now, and the product is calcium carbonate plus water. Now in the first chapter I have already told that calcium carbonate in nature exists as limestone or chalk. So therefore it is solid, and we will get a white solid when carbon dioxide gas is passed into lime water. So initially lime water is transparent. When we pass carbon dioxide into it, when we pass carbon dioxide into this lime water, then it will lose its transparentness and it will turn milky. Now it has turned milky because of the formation of calcium carbonate, which is solid. So when this solid calcium carbonate is formed, the lime water, which is transparent, will turn milky. This activity is very easy to do because we can exhale into lime water. When we exhale, we are throwing out carbon dioxide, and carbon dioxide will turn lime water milky. And that is because they will react to form calcium carbonate, which is a white precipitate. But suppose we pass excess of carbon dioxide into lime water, then the milkiness will disappear and lime water will become transparent again. This we can explain by writing a reaction between carbon dioxide and the solid product that is formed. So if we pass excess of carbon dioxide, calcium carbonate which is formed will react with carbon dioxide in water and form calcium hydrogen carbonate. Now calcium hydrogen carbonate is water soluble. It will dissolve in water, and therefore the milkiness will disappear and the solution will become transparent again. This is a test to find out whether the gas released is carbon dioxide. Carbon dioxide will also extinguish a glowing splinter or a matchstick which is glowing, and that is because carbon dioxide does not support combustion. So I just explained that if you pass carbon dioxide into lime water is initially transparent, it will become milky in nature, it will become cloudy in nature because of the formation of calcium carbonate, which is a white solid. But if you pass excess of carbon dioxide, then the milkiness will disappear due to the formation of calcium hydrogen carbonate, which is water soluble. So we will also find that carbon dioxide does not support combustion by showing that it extinguishes a glowing splinter. Another gas that we have to test for is hydrogen. Hydrogen gas, if you take it near a glowing splinter, then hydrogen gas burns with pop sound. So these are two gases that we can find out in the laboratory by doing these tests.